Okay, so for this problem right here, I'm going to go and ask you quickly, how many ways can you solve for x? Completely solve for x, meaning at the end I'm going to have x equals to some value. Do you remember how to solve this? If I just present you with this problem, what's the first thing that can come to mind? Yes, Jamie? X box in, right? Meaning, you have to utilize what we call, when you have 0 on one side like this, what property are we going to be using? Zero property. First one. So certainly you can do that. You can try to factor it out using x. In this case, do we need a box? No, because this is a 1 in front of the x squared term. So we don't need a box for the, but don't forget that it is okay for you to have a box. It's longer, but it still works out the same way. So that's the first approach. Utilizing factoring and zero product property. What about the second way? Do you remember how to do the second way? What did we learn last week that helped us solve this kind of problem? Let's say we cannot factor at all. Then what's another strategy to get around that? What is that called? What is it? Find, what is it? Find it? Find a missing square. But we have something for that. When we find that missing square, we put it back into that big square. What are we doing to the big square? Remember this right here? I know. Visually, this is what's happening, right? We find that missing square and we put it in here, right? What are we doing to the square? What is it? Say that loud. We're completing the square. So that's the second approach. It's called completing the square, right? And of course, for today, I'm going to show you another approach. It's a third approach, and we're going to have a formula for that. But in this case, let's review first out of the first two approaches just to get you to the right place. First approach, remember, factoring zero product property. We always look for things like, is everything in order?
Yes.
Do we have the 0 on one side?
Yes.
Always ask yourself that question. If you don't have it for an equation, don't even start doing anything until you have everything in order and that I have a 0 on one side, get ready, and we're ready to go. Once we have that, we can certainly attempt to factor. What do we put on top of this x right here? Negative 15. Negative 2. What times what a negative 15 add up to negative 2? Okay, you said 5 and 3. Will that multiply to negative 15? Negative 5. Good. So remember I told you we'll need a box for it because this is a 1. Therefore, we just certainly skip that. We can write it out as x minus 5 times x plus 3. That will equal to 0. And we have two cases, right? So x will be 5 and negative 3. 5 and negative 3. That's the first approach, using the zero product property. Easy enough. Is that true? But what I'm saying is, assume now that I'm trying to find this pair and I got stuck and I can't even find it. Then don't say, oh yeah, I'm going to give up. No. We have our second way now, and that second way involves completing the square. Completing the square, we still have to go through our usual checks, like, is everything in order? Do we have a 0 on one side? Another thing about the zero product property I need to remind you about is this number in front of the square terms a 1? Remember I told you it has to be a 1 for it to work? If this is anything other than a 1, what do you have to do?
Divide it by itself.
Yeah, divide it by itself, but not just one term, you have to divide every single term by itself. Imagine I have this here as 6. Then, to complete the square, you got to make sure you do this first. Every single term gets divided by 6 first. Okay, is that clear? If you want to complete the square. But it is quite good now that our actual problems doesn't have anything other than 1 front, so we're ready to complete the square. And when we complete the square, this is what we say. I have basically a box right here that is x by x, right? That's how I get the x squared. The negative 2x, meaning I have 2 tiles that is negative x each. So when I split into 2, I have a negative 1 tiles right there, right? This is by x, and this is another negative 1 tiles right there. Is that correct? And so the missing square, what's the dimension of the missing square? Negative 1 by negative 1. So that means the area of that missing square is a 1, right? So, but instead of having to draw this every single time, we have a way to get that answer, do we? We don't have to draw a figure every single time. What do we do to get that same 1? Remember how? Where do we get the side of the square from? The -2. Very good. Okay. So what do we do with this?
Square and then half it.
We square it first and half?
And then half
Look
it.
at we half first. Remember how we have to split this tiles into 2 pieces, right? One on each side of the square. So we half this first. When we half this, we get what? It's a 2. So when we half this, what do we have? -1. And isn't this the side of the missing square? And once we have the side of the missing square, how do we find the area of the square? So we square it. So we half first and the square. And that's how we got our 1. Does it make sense? But remember, if we find our square, then we don't need this at all. We've got to toss it to the other side because we already have a new square coming into our missing square to make it complete. So this -15, we need to toss it over to the other side when we complete the square here. So let's go back here and write this problem out. We now have x squared minus 2x plus 1, right? Because we just found our area of the new square. But watch what happened to the -15. I don't need it. We toss it to the other side. But don't forget, because we just have a new piece added in, we also have to do it to the other side as well. And that's how we got a 1 on this side as well. Does it make sense? Okay, so we solve this here. What would this become? What's the dimension of your complete square? What's the side of that complete square? X minus 1. And because it's the side, we just square it to find a complete area. Is that true? You know where this -1 came from, right? Because it came from that missing square side. Okay, over here, it will become, I'm sorry, this is positive 15, not -15. Because we add it over, we move it over. So that becomes 16. And how do we solve for our x? Square what? Square root or square? Square? Square. Okay, this is square. How do you undo the square? Yeah, okay. Square root it. So we have x minus 1 equals to 4? Just 4? Plus minus 4. Don't forget the 2 cases. Reasons. -4 squared is still a positive 16. Positive 4 squared is still a positive 16. That's why we have 2 cases. And we add the 1 over, as you can see. We have now what?
X equals plus minus 5.
Okay, so first of all, 1 plus 4 is 5. And 1 minus 4 is? -3. And is that the same answer we got from before? Got it? See how we got it, right? So that's the second approach. Any questions? So, yes?
When you do it like this and do it the other way, on the other way the 5 was negative and this one is negative.
On the other way, the 5 was negative? Was it negative on the other way?
No.
No. The 5 was positive, right? What do we get on the other way?
X minus 5 times x plus 3.
Yeah, so when we solve it, it's positive 5, -3. What we solve for x? Because when we factor, remember, don't we get x minus 5, x plus 3 equal to 0? When we solve for 0, is that still 5 and -3? So it's the same thing. Okay? Question on it so far. So this is the second approach, completing the square. And I'm going to go and show you this third approach today. And that involves a formula. By the way, the complete derivations of the formula and how I got the formula to begin with, I will post that separately online for you. So if you want to see why I got the formula, then yes. Okay, all right, here we go. That will be online with this video as well, okay? So take a look. Today I'm going to show you a third approach, and we call that third approach using the quadratic formula. So let's spell it out for you here, the quadratic formula. And first of all, we'll have the quadratic formula. The quadratic formula is actually pretty good in terms of it doesn't care whatever you give it. It will just take it as is and just solve it for you. So imagine what we just started out with, x squared minus 2x minus 15 equals 0. So I'm going to go ahead and use the same exact problem. And I'm going to use this third approach to solve for it. And at the end, you'll see that you get the same exact answer as well. Okay? So what is this magical formula? What is it all about, right? So first of all, that quadratic formula, for you to start this, you always have to check a couple things too. Meaning, do I have it in the right format yet? Meaning, all the terms on one side, there's a 0 on the other side. We call this the standard form. Notice I'm using the A and the B and the C because I don't know what number they are yet, right? So this is just standard, applies to any format anyway, any numbers. So I always check to make sure that I have everything on one side in order, and that there's a 0 on one side as well, on the other side. Okay, so always check for orderliness before you start solving. And of course, check to make sure that I have everything there. We're good? What if something is missing? Then what will happen then?
You can just add.
What if I have just this? What would happen?
It's 0.
Yeah, 0 for what term?
That term.
The x, right? Very good. So anything's missing, you certainly fill in with a 0 term for it. Just like how we learned to use long division before. Anything missing, we can certainly do this. Oh yeah, since the b x term is missing, I can certainly do this. 0x, right? Minus 15. And that's whatever's missing, you fill in and complete it. Okay?
Oh.
You see what's happening there?
Uh-huh.
Okay. Because I need to make sure I always have 3 terms on one side. And the other side has to be 0. That's a precondition before you start your quadratic. Now quadratic doesn't care about what's in front of each term. The coefficient I'm talking about. Unlike the completing the square, where you need to have a 1 in front of the square term, quadratic formula doesn't care. As long as you have 3 terms, and the 0 on one side, you're good to go. So watch what happened here. What you need to do is, another thing too, that what it cares about is A cannot be a 0, guys. Okay, you don't want to have A cannot be 0. Because if A is 0, it's no longer a quadratic. You just have yourself a linear, right? So be very careful on that. A has to be there. Whether it's 1 or 2 or whatever, I don't care what number it is, but it has to be there. Now, when you go back to your equation, first thing you want to look for is pull out all of your coefficient. Now, coefficient means what? The number in front of the variable, right? So pull out all the coefficient. In this case, this number in front of the square terms, the x term, and the 15. Since we already have everything in order, all you have to do is just write out as A, B, C. Look, A, B, C. This is the reason why I always force you to write everything in order. Because once you have it in order, you can just name them A, B, C like that. And A, what is the coefficient in front of the square term? 1. So you just write A equal to 1. What is the coefficient in front of the x term?
-2.
Then you write -2. And what is C equals to? -15, because that's just a number. And there you have it. You got A, you got your B, and your A, B, C's, everything's there. Is that easy enough so far? Yes? And then what you can do after this, right? Well, here it is. Here's a big formula that you want to start writing down. X equals to -b plus or minus the square root of b squared minus 4 times a times c, everything over 2 times a. Don't forget, there will be another video that goes with this to explain how I got that formula. Okay, so check it out.
We have to.
Yes, guarantee you need it. Okay, so this is what you need to memorize for now. And once you see the other derivation, it makes more sense. Okay, so all you have to do is have this formula right there and start plugging in. What is B?
-2.
-2. So I'm going to go and start plugging in. Oh, by the way, every time I plug in something, it's a good habit to put it inside parentheses. Because I plug in a -2, and don't forget there's a negative already in front of it, I also make sure it's there. See, I insert a -2 into B, but in front of B, there is a -2 already, right? So I have to put it there with the value as well. Plus or minus B squared, in this case, it's -2 squared, right? Minus 4 times A is 1 times C, which is -15, right? Everything over 2 times 1. And there you have it. I just replace every variable inside the quadratic formula with the one that I know, and I'm going to start solving for it now. Remember I told you that in case we have missing terms, we certainly always fill in with a 0 term. And that coefficient is going to be a 0. Okay? But now since we have everything there, we're just going to use as is. Alright, let's simplify our equation. A negative and a -2 becomes what?
2.
2. plus or minus. Here, what is negative 2 squared?
4.
4. What is negative 4 times 1?
Negative 4.
Negative 4 times negative 15.
Positive 60.
Positive 60. So I'm going to write positive 60. See it? Everything over 2. It's getting easier, huh? Okay, what is 4 plus 60?
64.
64. So I'm going to write x equals to 2 plus or minus square root of 64 over 2. Oh, wait. Isn't square root of 64 a perfect square number?
Yeah.
Which is 8. So I'm going to have two cases. I have 2 plus 8 over 2. That's the first case. Second case, I have what? 2 minus 8 over 2. So let's solve. What's 8 plus 2 divided by 2?
5.
5. What is 2 minus 8 divided by 2?
Negative 3.
Negative 3. And isn't that the same exact answer as we got from before? So the two approaches that we tried before, using completing the square, using the zero product property after factoring, and we use a quadratic formula, they proved to be exactly the same. And this is what the quadratic formula is all about. Question on that? Who thinks you're going to be using this approach? I know, it can be lengthy, but one thing is, if this is not factorable at all, then you definitely want to use this, don't you? Is that true?
Oh, so it just works in every problem?
How to? No, it's the formula. That's the formula.
What's the formula?
Yes.
You have to learn it?
Yes, it's a formula, right? It's there for you. You just have to plug it in.
Oh, like,
Okay. All right. One more thing I want to talk about before we move on to the next example is this term. I want to talk about this piece inside the square root sign. And that, what I circle inside the square root sign is called the discriminant. Write it down, please. The discriminant. Okay? Now, what is that? Well, actually, the discriminant is just basically a warning signal to tell you how many solutions you expect to have after you're done solving. Okay? Notice that for this particular, the problem that I just erased, we got how many solutions at the end? 2. But you know that sometimes we have other solutions too, and I want to talk about it. Here's the reason why. The discriminant is inside of your square root sign. Okay? Now think about this. How many possible ways can you get inside there? First of all, the discriminant could be what value in there? 0, that's 1. Positive, what else? Negative. So you have 3 choices. The discriminant could be a positive, which is greater than 0. The discriminant could be exactly 0, because you never know. You might subtract something and you end up getting 0 for it, right? Or the discriminant could be less than a 0. Less than a 0 means you obtain a negative value after you solve it. Now watch what happens though. So I'm going to use D, letter D for discriminant, for short. Think about this. If I have a positive value inside the square root sign, just like our previous example, square root of 64 is 8, right? So when we solve for it, clearly you see how many solutions that we have at the end? 2. So that means it proves that every time you have a positive value inside the square root sign, you are guaranteed to have 2 solutions. Guaranteed. Okay, let's take a look at this case right here. What if the inside of your square root sign is a 0? What is the square root of a 0? 0. So if it's 0, if you take a number, add it to 0, will that number change?
No.
If you take a number and subtract 0, will that number change?
No.
So in that case, when you have the discriminant equals to 0, how many solutions do you expect to have if the value doesn't change at all?
0.
Think.
A lot.
A lot? Think about it. Remember our last case here, we got what?
2.
We got 2 plus or minus 8, right? Over 2 at the end, right? What I'm saying is, what if this discriminant, instead of being an 8, what if it's a 0? Then, am I going to have 2 solutions still?
No.
In this case, how many solutions am I going to have?
1.
Just 1. Because when you add and subtract 0, you still have the same exact value on top. Right? Therefore, I only have 1 solution, and that is a good indicator too that every time I have a 0 inside the square root sign, I expect to have only 1 solution. Clear on that? So this is just like a warning sign to tell you how many solutions you expect to see. The last one though, think about this.
Is more.
If you have the discriminant less than 0, less than 0 is like this. Oh yeah, inside I have negative 16. Can you take the square root of a negative 16?
Yes.
Yes, you said yes. Tell me then. Can you find me a twins that will give you a negative 16 when you multiply? See, you said yes. That means you need to have a twins, right?
Yeah.
But can you find it?
No.
Okay, if the answer is no, then let me ask the questions again. Can you take the square root of a negative value?
No.
No. If you cannot take the square root of a negative value, will you ever have a solution?
No.
No. So in that case, when we have a negative value for the discriminant, how many solutions am I expect to have?
0.
0. Okay. And that's what I want you to understand about the discriminant. So discriminant is just like a warning sign. I don't want you to have to go through the entire problem solving to the very end to realize that I have no solutions. And instead, catch it early on. When you get to this point right here, inside the square root sign, if you have a negative value in there, stop and say, oh, no, there's no point in solving because I know I have 0 solution. If you have 0 inside the square root sign, you know you have exactly 1 solution at the end. If you have a positive value inside the square root sign, you know you have 2 solutions at the end. If I ask you to just give me the discriminant, well, it is what I just circled. The inside the square root sign, that value inside it, is called the discriminant. Does that make sense? Okay, so, very good. Take a look at this next example right here and ask a couple questions here. See if you're ready to go. Is this, I know you can say, I can certainly do first step, it's factorable. I can do 0 product property on that. What's my pair? Negative 18 and 3, right? What's that? 6 and negative 3. That works. And so I know, before I start solving, I know that my answer is negative 6, is plus 6 and x minus 3, right? I can solve that. I can get negative 6 and positive 3. Or I can complete the square and get the same exact solution. True?
Yeah.
Or, now I have my third way to do it. Let's try the third way. Check the third way out. Is this, what are the couple questions I want to ask before I start using the third way? Or any other way? Is everything in order? Very good. Is everything in order? Everything's there too. Any missing term, I have a 0 for it. But in this case, I have everything. Okay? So let's pull out the value. What is my A? What is my B? What's my C? What's A?
1.
1. What's B?
3.
What's C?
Negative 18.
No. It's right here. I don't make up my own.
Oh.
That's why I asked you to put it in order before we start, right? Because when you put it in order, you will have A, B, and C right there. Just like how A, B, C is in order. They're in order. A, B, C letters, they're in order, right? Does it make sense, Trent? Okay, so once you have that, you pull out just the coefficient in front of your terms, and that will make up your A, B's, and C. Okay? And once you have your A, B's, and C, now you can write your formula. And hopefully you can actually remember it in here, so you don't have to be reminded every single time. There. See it? Negative b plus minus square root of b squared minus 4 times a times c over 2 times a. If you can say it fast enough, that means you're good. Huh. Who can say it faster?
Karen.
Karen? Okay. All right, let's plug it in. Negative whatever b is. What is b? 3. So negative in front, so it's going to come a negative 3, right? Makes sense? Plus or minus b squared. What is b again?
3.
So square it.
9.
9. So could I just write 9 instead of having to write 3 to square? Okay. Next one. 4 times a. A is 1. C is negative 18. Everything over 2 times 1, which is just 2, right? So if I can just simplify it in my head, do it. I don't have to force you to do it. Moving on. Equals to negative 3 plus or minus. Okay, let's check it out. This is 9. What is negative 4 times 1?
Negative 4.
Negative 4 times negative 18.
Positive 72.
Positive 72. Oh, look. Before I start solving again, I look inside the square root sign, and what's that value?
81.
81. That 81 is called?
Square.
No. What is that called? The discriminant. Discriminant is positive value, so I expect to have 2 solutions. See it? So at least at this point in time, you know the discriminant is 81, isn't it? So here it is. 81 it is, everything over 2. Moving on. Square root of 81 is? 9. So now I'm going to write negative 3 plus 9 over 2. The other case, negative 3 minus 9 over 2. What is negative 3 plus 9?
6.
Huh? It's a plus and minus.
Oh.
One's plus, one's minus. Right? So 6 over 2? 3. What's one answer? What about the other one? Negative 3 minus 9?
Positive 6.
Negative 12.
Negative 12 over 6? And is that the exact answer we got from before? Will we factor using the Z to P? Yeah. See? Third way works too. And, you know, I do expect that you start practicing the third way. It's the quadratic formula, right? There it is. Okay. And just like what it says, the discriminant tells you how many solutions you have. It's a positive. I expect 2 answers. If this thing is a negative, you don't have to move on. Moving on here. Okay, is this ready to go?
Yeah.
Look at it.
No.
Is it in order?
No.
No. So it's not ready to go. What do you have? How do you arrange this to make it ready?
Move the 17 over.
Subtract 17. So watch what happened. I'm going to go ahead and subtract the 17 over, and this is what I have. Is this ready to go?
Yes.
Yeah?
No.
Okay, let's say he said yes. What's my A? What's my B? Oh yeah, it is. Very good. It is. Who said no?
Never mind. Never mind.
Jocelyn. No. If okay, I'm sorry. If I wrote it like this, you would have said
No.
no. Reasons?
Because it's not.
It's not in order, right? But it's obviously in order for the first one, so I'm good to go after I rearrange it. What's my A?
4.
4. What's my B?
2.
What's my C?
Negative 17.
And you see why I asked you to write in order? Trent? You see why I asked you to write in order now? Look, because if it's in order, A, B, C, right there. All the coefficients there. And notice, if you were to complete the square, or if you were to use X box on this, you would put 4 times negative 17 and do an X box, right? Or if you were to complete the square, you would have to divide everything by.
I don't know.
Remember, completing the square requires this to be a 1 in front of the square term.
Oh, yeah, just divide everything by
Then you
4.
have to divide everything by 4, which makes it even harder, right? That's the reason why we have our third way now. The third way, we don't really care. All you have to do is just pull out A, B's, and C, plug them in. That's it. So for those of you who don't like completing the square, having to divide everything by the number, yeah, then you use the third way, yes.
Why didn't you just show this one instead of just the
It's called step by step. You know, some people. Oh, by the way, I mean sometimes it's a lot easier just to do X on it because it's easy, right? This one's like the last resort where you cannot factor and you don't want to complete the square because it's too much. Then you just pull out A, B, C, and plug it in. So here's a formula. Okay, recite me the formula, please. Oh, okay,
X.
Gary.
Oh.
What's the first thing I should write after X equals?
You got it.
What is it? What is it, Gary? Did you write it down? Can anyone help Gary? What is that going to be right after the equal sign? Negative B. And then after the negative B is?
Plus minus.
Plus and minus. And then what happens after the plus and minus? Uh-huh.
B
squared
minus
4AC divided by 2A.
That's it. Did you write that down? It's there. Okay, moving on. X equals 2. What are you plugging in here?
2, negative 2.
Okay, well, 2 and then it becomes negative 2, right? Plus and minus. Inside here, B squared is going to become?
4.
4. Minus 4 times A, which is?
4.
4. And C is?
Negative 17.
Negative 17. Everything over 2 times?
8.
4, which is 8, right? You know how I got the 8 in the bottom, right?
No.
What's 2 times A? What is A?
2A.
What's A? Look,
Oh, 4.
4. 4 times 2? Okay, never mind. I'm just going to write out. Okay, here you go. 2 times 4.
Oh.
Okay. Okay.
Oh, you replace it?
Yeah,
Oh.
you got it. Okay. Moving on. X equals 2. Negative 2 plus or minus 4. Okay, let's multiply this. What is negative 4 times 4?
16.
Negative 16. What is negative? Oh, you know it's going to become positive because the negative times the negative. So 16 times 17. Let's multiply that. What do you have?
272.
272. That's like correct, right?
Yeah.
I was assuming. Okay.
Yeah.
Everything over? 8. Huh?
No, right?
Okay. Alright, so, and then you add that, what do you have? X equals to -2 plus or minus 276 over 8. What is the square root of 276? Is that a perfect square number?
I think so.
No, huh?
No.
Okay. Then we can just do it the best we can. Either get it back to a decimal number or leave it in simplified form. So we simplify 276.
Yeah.
Okay, let's break it down. What do we have? What can we divide 276 by?
1.
We can do it by 3, right? So we divide by 3. 3 times 92. And we can break 92 down to what? 2 times what?
46.
46? Right? And we do 46 again. So far we have 2 times 2 times 46, and 46 is what? 2 times 23. And 23 is a prime, can't do anything, but at least we see the pair right there, isn't it?
Yeah.
So we have 2 root 46, right? 2 root 46 is what we have. Oh, come on. Okay. Alright, so we have -2 plus or minus 2 root 46, everything over 8. Okay, and we split it in, and write 2 cases, 1 plus, 1 negative, and we just leave it like that. That's fine. Or we can simplify this a bit more too. For example, isn't 2 over 8 1/4?
Yeah.
So if you simplify that, here's the first case. -1 plus root 46 over 4. And the other case, -1 minus root 46 over 4. Because I also simplified the fractions. Okay, so there's 2 cases right there. I can leave it like that. If you want to turn it back to a decimal, you take the square root of 56, whatever that number is. You can certainly add and divide. It's your choice. But notice, that's what's happening. Obviously, if you were trying to factor this thing using Xbox, not going to happen. And you try to complete the square, it will work too, but it will take longer. That solves this anyway, so might as well use the quadratic formula. Check this one out. Who's correct? Lakeisha or Juanita?
Check carefully.
Why?
She's Mexican.
Why?
Because she forgot to take move the 2 over.
Lakeisha forgot to move the 2 over. Juanita did, huh?
Yeah.
She ordered that thing. Very good. She ordered it. Alright, so it's all good. Fine. Moving on. Here's your recommended month for tonight. We got page 119, 7, 15, 17, page 124, 9, and 11.
Don't change it.
Oh my god.
Okay? These come from your white workbook, guys, so make sure you circle them.
Okay, you can change it.